Righto, so we're just going to have a look at a few things to do with metals. You're also going to have to describe non-metals, and you'll see in today's experiment, in the little trays you've got, there's some things that are metals and some that are not. And we have to work out which ones are which and that sort of thing. What I've got set up here is a circuit where I've got the leads, so there's wires, the colours don't matter about these, okay, they're just there to help us keep them separate. Plugged into what's called the DC. Okay, so there's a plus and a minus. So I've got a lead connected to the plus that is connected to this thing here called a crocodile clip. Okay? Then, so we're going to do that. Then on the other side we've got it connected to a lamp. And then the other lead coming off the lamp is also connected to a crocodile clip. This is so we can put things in between to see if they make the light bulb go or not. So the two things I want to look at, one is a metal and one is not a metal. The first one is going to be wood, so the ruler. If I clip it on there, sorry, I'm first going to check that the circuit does work without anything in there. So I'm just going to touch the two sides and the light bulb goes. So I know that this is what we call a complete circuit. So if anything's in between them that doesn't conduct electricity, like air doesn't conduct electricity because it's turned off, but the bench does. It's quite safe. The wood for the ruler, let's see, what do people think? Will it conduct?
No.
Let's see. If I put it too close, it will. But you're quite right. If I clip that on there, then it doesn't go. So wood doesn't conduct electricity because the light bulb didn't go on. This is this awesome stuff, magnesium, that you've burnt and done a lot of playing with. Let's have a look at that. Now this is a metal. Oh, just said spark there. That's pretty cool. So that does make the light bulb go. So what we call this is, this thing here, the magnesium, is a conductor. Alright? Just like someone who runs the orchestra or someone who tells the trains where to go, that sort of thing. So it's called a conductor. Right, I'm going to get rid of those. And so this is the setup you're going to do. But this is not the only thing I want to look at about metals. If you have a look at this metal, it's quite shiny, isn't it? Sort of reflects a little bit, reflects a bit of light. And if I was to get sandpaper and rub it off, it would shine even more. The word that we use in science for that is luster, L-U-S-T-R-E. I will write that on the board shortly. So anything that's shiny, whether it's a metal or a non-metal, doesn't matter. If it's shiny, we say that it has got luster. It has got luster. So all that magnesium, if I was to sand it off, would have really high luster. That's the way we describe it. The other thing you'll notice is that I can bend it quite easily without breaking it. I haven't broken it, have I? I've bent it so it can be reshaped. I can change its shape without breaking it. This is called malleability. M-A-L-L-E-A-B-I-L-I-T-Y. I'll put it on the board. Alright, so it's malleable. It can be changed shape without breaking. The other thing is that if I was strong enough, and I'm not, I could pull it into a wire. So like the leads in here are copper underneath the plastic. I could make it into a wire by pulling it if I was strong enough. I'm not. And that's called being ductile. D-U-C-T-I-L-E. Again, I'll put it on the board. So these are some common properties that all metals have got. They've got luster, especially if you sand them off first. They are malleable, can change shape. They're conductors. And they are ductile, they can be pulled into a wire. As well as that, they can also conduct heat. They don't just conduct electricity, they conduct heat as well. So they're pretty awesome materials. You'll also find that almost every element on the periodic table is a metal. Not many of them are non-metals. So you'll see that if you look on the periodic table and you go, what symbol's that? And you look at its name up on the periodic table over there, it's probably a metal. And you'll see there's a little blue diagonal line on the periodic table. That tells us which one's the metals and which one's the non-metals. Harry, you're probably well placed. Which ones do you think are the non-metals? Left of the blue line or right of the blue line? On the right, do you think they're the metals? So carbon and... That sounds better. They're the non-metals on the right. Oxygen and nitrogen and all of those. So things like iron, Fe, magnesium, Mg, they are our metals and they're on the left-hand side. So if you're not sure what substances you're using in your experiment today, see if they're on the left-hand side or the right-hand side of that blue line on the periodic table. Okay? Can you stop the video there?